So we're concentrated in the construction sector, and ultimately we're, as a research group, trying to stay on the innovation path. And so we started 10 years ago with this goal to reach net zero. And net zero is really a building that produces as much energy as it consumes annually. And more that's becoming part of the market. We're starting to see more and more buildings take up that goal. And if you travel at all, or even in Western Canada and Vancouver, many of those buildings are really pushing those standards. And so now we're either pushing it further to see what more we can do, or we're actually doing a lot of training, because after all, we're a college. And so part of our job is to get people learning how to design these things and make them more affordable. So this is a particular house called Discovery 5 House, and this is a little net zero home that we built as an urban infill in the city. And what we ended up is sort of a bungalow beside it, and we were able to sort of actually lift that up and ship it off to Red Deer. Someone now lives in that house. But then the business case was building 2 side-by-side houses and selling one of them to pay for the upgrades of the other. SAIT students worked on this house on site, and we actually shipped it to site, transported it, and craned it in place. We've worked on houses up in the north, so this is actually a house up in Fort Simpson, which is in the Northwest Territories. And their power costs a ton of money, so it's not uncommon that people are spending $900 to $1,200 a month in the wintertime to heat their homes. So suddenly, super insulating and adding renewable energy makes a lot of sense both financially, but also keeps things more durable and a little bit warmer. These are other examples of some of the houses we've done. The one in the bottom right actually was a competition house, and it ended up being modular. So it went to Washington, D.C. and sat on a mall for a while. It was out at the Vancouver Olympics. It's actually back in Calgary right now. This one over here on the other side, a good example of that was some product innovation. And so you can see the shutters in front of the windows there. They're inset into the wall and look like a standard shutter. But part of the development of that was working with engineers to come up with a new type of product. So they actually heat all the domestic hot water, and the railing system provides all the space heating for the entire home because they're solar thermal. So these are the kinds of projects that we work on, and we're starting to see more and more transitions. So folks like Mattamy Homes and some of the bigger builders like Landmark Group and whatnot are starting to adopt these standards and find ways to make them affordable. And the important part of that is that we end up training everyone from carpenters that are building the house to the inspectors that are actually reviewing the house because they have upgraded materials in them. But industry comes to us with product ideas as well. So this is a new type of rough opening that we worked on, and so it would go inside a typical home, replacing windows and doors and things like that. But it's a click-together system that's really fast, it's accurate, it means your finished carpenters have to do less work. And so we work directly with framers and builders to not only trial these products, but also the supplier or the inventor to sort of improve that product so it's ready for market. And we've done that on a couple different things, like that railing system where we're able to shrink down what used to be a big railing system and actually make a patent and make a new type of solar thermal balustrade or balcony railing. To some of the quirky things. So this is a soap bubble insulated greenhouse. Again, if you're looking at sort of 4-season food production, one of the things that SAIT wanted to do was teach its culinary students, all the cooks and chefs, where their food comes from. The problem is that teaching students how to cook in Canada with our cold climate is not always the easiest thing to have gardens in the middle of December. So we built a 4-season greenhouse, and in order to make it interesting, we heated it with the waste oil from all the kitchen fryers, and we insulated it with soap bubbles. And so that's one of the folks on my team getting to play with foam, which ended up being about our 1.5 per inch. So that greenhouse was insulated better than most people's homes. But the light still came through it and was able to grow plants. And so as we start working with different groups, you end up with a bunch of really interesting trades that come through. So in this particular case, this is a group of people that was trying to modularize a concrete product. So this is hemp and lime and a bunch of other flax materials. And it was a bunch of kids that actually came off a farm in Saskatchewan. They were trying to come up with a waste stream for their dad's farm. And they came up with a wall system. And the wall system, they first started stirring it in giant garbage pails with a paddle. We then got them into using basically the equivalent of baker's mixers. And then we ended up making a truck that was the equivalent of a baking paddle mixer, but at a large scale. And now they're doing full wall systems. So this is the preliminary testing and mix ratios that we needed to do in order to get them to make sure that that wall would be as structural as any other kind of structural wall. But the key thing about that is that they really just had a product. They knew that they could do something with it. They were helping their dad out. And now they're running a building supply company and doing very well. Two other folks that are coming through saying, I have another idea. I want to try putting sensors in systems. And so this is where students that are going through SAIT's either IT program or the electrical engineering program, learning more about data management, data monitoring, data analysis, can actually interact with new products on the market and start seeing how they would perform. Right through into sort of structural compression. So the civil engineering techs that would come through would be able to try how to sort of test out new things that are on the market. And so you end up in an environment where every single product that you would actually see and use in a building goes through multiple steps and needs to touch a bunch of different people. This is a off-grid water closet, otherwise known as a toilet or porta potty. We ended up building this for Parks Canada, and lo and behold, I ended up flying out into sort of Wapta Reserve territory and sort of completely off-grid in these remote areas and dropping these things in place so that they can biofilter and get rid of all of the water and reduce the waste and self-power these items so that you don't end up having these sort of really expensive, basically, porta potties in the middle of the Parks Canada. You can end up with something like this that actually treats it environmentally and treats it really well. There's some energy management that's part of this, and so measuring is a critical component to research, and understanding that as you guys proceed with a new or an innovative idea, monitoring what you're doing and measuring it and improving upon it is a critical aspect to how we make production and how we move forward. And so it's a huge part of what we do, and we started with just houses and now we measure pretty much everything. And because it's actually evolved so much over the last 10 years, now everything's smart managed. So we went from just sort of simple electrical monitoring in a house to now we're doing full asset control and using smart controls to open buildings, to have a room like this, have an occupancy sensor in it so we understand how many people are here and we can ramp up the lighting and the ventilation so you guys don't fall asleep on me as I talk, right through to being able to predict when things would fail. So now we're actually in a point where there's 3D imaging where I can put on a set of glasses and I can toggle through an architecture set or a construction set in a building that is under construction, and I can visualize through virtual reality where I am in the building and what I need to build. I now no longer need to have a set of plans. I can actually see them in my glasses as I walk through a building. You can see the pump that needs to be there. But more importantly, after the building is built, I can go back to that same pump and say, here's how it's been performing. It now has an alarm that says, here's when it will start to fail. And so you start seeing predictive trending. And that kind of intelligence being brought into the building industry is drastically changing how things are done. To some quirky things. So this is a great example where City of Calgary actually came to us and they said, hey, we realize that there's other cities that are cooler than us, which is a big thing for a city to do. Why are all these cool projects happening throughout the States or throughout the world? Why aren't we doing them? One example is there's a bunch of these kind of container projects all over the world where people are setting up their own store. Before you can afford a retail outlet or before you can afford something that's big, there's like that food truck entry level kind of point. What can we do? And maybe containers is the way to do it. Maybe we can sort of rent one for a month to month and see how it goes. A lot like a flea market. But how do we go about doing that? And what they realized is that they were the ones that had all the restrictions. It wasn't that there wasn't a business for it. It was that there are so many restrictions that the city put on making these things happen that we need to get rid of them. So we worked with them to overcome that. And now there's a couple container pods in the city that are supporting young, new businesses, from folks that want to make chocolate to folks that are doing distilleries for new types of gin. To bigger things. So this is an example of concentrated solar thermal. And so there was down in Medicine Hat, there's some concentrated solar for electric production. And it's not doing very well. And we're wondering why. Like it's working really well in other parts of the world. Why can't it work in Canada? And part of it is cold, but part of it is because sometimes we just need to add that extra piece. So this is actually a group called Glassdoor. And what they do is they put a greenhouse around their solar facility for Canadian production. So it's really great for steam and heat. And you can grow food in these things at the same time. And we're starting to see them more and more at a utility scale, particularly on a campus like Keano, where you need a lot of heat for all of the different buildings. You can have something like this in a greenhouse, and it provides a ton of steam for